be taking out their diagram. If you look in the front of the room right now, this is what we're going to be writing in. Quickly. This is what we're writing in. So see how much words we're putting in, how much information, how much detail. So as you are doing this today, please make sure you're writing small and write it where I tell you to. Don't do anything I'm not doing. Write as small as you can, but legible, of course. And write it exactly where I write it. So this is your last week of anatomy, I promise. We are just about done. First thing this week we're doing the ear, and then tomorrow we're doing the eye. Like I said, all of your other classmates are ahead of you, so you may have to just watch my video on the eye. I'm going to try to get through it as much as I can, but keep in mind we are a little bit behind in this class. Thank you, Bailey. So here we go. So first thing we're going to label is your pinna. Now write it where I'm writing it. Please write small. Now your pinna is the outside flap of your ear. In this funnels, P-I-N-N-A. This funnels sound waves into your auditory canal. Okay, so if you take your hand, I'm sorry, my hair is down for the first time all year. If you take your hands and put them behind your ears and kind of push it towards me, do both. It's better if you do both. You can tell you can hear me better. True or not true? The more you pull it up, all of a sudden I'm louder in your head. How strange. If you pin it back, I sound further away, and the flatter you do, obviously I'm not going to sound like I'm 3 miles away, but I am going to sound different. It's because there's a lack of friction. Now, the reason why you have these folds in your ears is actually to break up the sound. If you just had flat ears, the sound would bounce off your ear and wouldn't be funneled in, and that's why you have all these flaps that kind of curve in. Isn't that cool? Anyway, all right. So that's your pinna. This is your auditory canal. Okay, also known as your ear canal. Well, we don't call it the ear canal. We call it the auditory canal. Now, over here is your tympanic membrane. Okay, now your tympanic membrane also is known as your eardrum, but we don't call it the eardrum. We call it the tympanic membrane. Okay, now there are 3 different types of energy your ear processes. The first one, sound waves. The second one is physical movement, and the third one is liquid movement. And we're going to go through. The ear has 3 different stages of transduction, or how to process sound into a neural impulse. So the first stage is your outer ear. So we're going to write outer ear. And the first thing it goes through is the pinna, which then filters or pushes the sound into your auditory canal. Okay, so it goes from your pinna to your auditory canal, then to your tympanic membrane. Okay, and that is all of your outer ear. You're going to take a color pencil or crayon. I don't care which one you use. For me, I am doing blue. Okay, so for me, I'm going to draw a box around my outer ear, so when I see blue, I know what I'm talking about. All you need is 3 colors, by the way, so you can totally share. So I'm going to color in my pinna. I'm going to color it in super quick because we're not here to color, but we need to label inner, outer, and middle, so we might as well color coordinate them. So here is your outer ear. You're going to color in your auditory canal and then to your tympanic membrane. Now, because there's 3 stages in every ear, there's going to be a lot of overlap because our ear depends on every single component to do its job. So the tympanic membrane is going to be the end of the outer ear and the beginning of your middle ear. So your outer ear is everything you can touch with a Q-tip. Okay, a nice easy way to think about it. If you can touch it with a Q-tip, it's got to be in your outer ear. Okay, so your outer ear is here to here. Okay, so yes, you do need to know all 3 stages. Yes, you do need to know how your ear processes information. So your next stage is going to start your tympanic membrane. Now your tympanic membrane is then, so sound waves are going to be funneled in by your pinna into your auditory canal. Once it hits your tympanic membrane, it vibrates. Okay, so the vibration of the tympanic membrane is what is processing the original sound waves. I'm going to write sound waves because this is what it processes. Your outer ear processes your sound waves. So as the sound waves are being funneled into your auditory canal, they hit the tympanic membrane, and the tympanic membrane starts shaking. On the other side of the tympanic membrane, you have ocelles, or bones. They're the smallest bones in your body that are pressing against your tympanic membrane. So every time the tympanic membrane moves, all of a sudden now we have a mechanical movement, or your bones start moving. So every time, like right now, you're hearing my voice, your tympanic membrane is vibrating, and that vibration is causing the ocelles to start moving. So it takes sound waves, converts sound waves into a physical or mechanical movement of moving the bones. Isn't that cool? All right, well, here we go. So your next step is your ocelles. Ossicles. Now your ocelles are broken up into 3 bones. They are the anvil, the hammer, and the stirrup. Yes, you do need to know, but keep in mind they're in alphabetical order. So that's nice. Okay, the anvil, the hammer, and the stirrup. These are the 3 bones right here. So as the tympanic membrane vibrates, these 3 bones are starting to move. So we've now converted sound waves into a physical movement or a mechanical movement of the ocelles moving. And then we have right here the oval window. Now the oval window is the connection into your inner ear. The oval window is, as you can see, it's a little bit of a horse, the stirrup is attached to it. And it's like, have you ever seen a diaphragm? You know how like if you put like a balloon on top of like a 2-liter bottle and you pull up the air and push down the air, the water level moves? It's just like that. Every time the bones move, so the tympanic membranes vibrate, your ocelles vibrate. Every time the ocelles push on the oval window, it pushes in and pulls out, pushes in and pulls out. Inside, on the other side of the middle of the oval window is mucus. So every time your ocelles are moving, it is moving mucus behind the oval window. So we now have our 3 conversions. But before we get too far, so your tympanic membrane all the way to your oval window is going to create your middle ear. Okay, and your middle ear for me is going to be yellow. So middle ear begins with your tympanic membrane, so there's overlap here. Includes your ocelles and your oval window. Okay, and I'm going to label that, and then I'm going to go down here and write in middle ear. Now your middle ear is taking the energy created from converting your sound waves into physical movement. So I'm going to do physical. Okay, so it's physical movement. It's no longer sound waves being processed, now it's a physical movement. And it goes tympanic membrane, to your ocelles, and it's anvil, hammer, stirrup, and then goes to your oval window. Okay, so your middle ear is the physical movement, and it moves. It goes from your tympanic membrane to your ocelles, anvil, hammer, stirrup, alphabetical order, and then your oval window. So far, your pinna is funneling sound into your auditory canal. Those sound waves are then going to make your tympanic membrane vibrate. With every vibration, the tympanic membrane, it's making the ocelles move, and that is now taking the sound waves and converting it into a mechanical or a physical movement. So now all of a sudden our bones are moving, and it's pushing in and out of the oval window. And the oval window is the beginning of our inner ear. Ellie, what do you got?
So just to clarify, the yellow is only in like the lighter gray area.
Yeah, it's only in this little spot.
Okay.
That's it. All right, so this right here is your cochlea, C-O-C-H-L-E-A. Now your cochlea This is filled with mucus. Someone asked me on Friday, is it green mucus or white mucus? In my head, it's green. I don't really know. It's filled with mucus and is where transduction occurs on the basilar membrane. Okay, so the cochlea. The cochlea is the snail-looking thing. Inside the snail-looking thing, you have mucus, but more importantly, you have the basilar membrane. So you're going to draw that in now. I'm just literally adding a layer to it. What? B-A-S-I-L-A-R. Let me write it right here. Basilar membrane. Okay, so inside the cochlea, there is a layer called the basilar membrane, and this is where transduction occurs. Okay, and this is actually where transduction occurs. All right, so inside your cochlea, you have the basilar membrane. On the basilar membrane, you have cilia. Cilia, or hair, that stick out of the basilar membrane are where actual transduction occurs. Now, what happens is the whole cochlea is filled with what? Mucus. So every time the mucus moves, guess what else moves? The cilia. As the cilia or the hair moves, that is what making neural impulses. So, all right, so we're going to draw a box down here. Okay, so this is inside your cochlea. Okay, so inside your cochlea, you have the basilar membrane. Okay, we have little cilia. They're curly, apparently. I don't know if they're curly. I have really no idea. Okay, and this is your cilia. So your cilia are attached to your basilar membrane, and then you have mucus. And we're going to color this in to make it a little more. So as the mucus moves, our basilar membrane, our hair goes in different directions. Can we agree? So as it moves, it then creates a neural impulse. Every time it moves, a neural impulse is made. Okay? So every time it moves, a neural impulse is made. So I'm going to color my basilar membrane. Mine is going to be yellow. My mucus is going to be green because that's what it feels like it should be. Okay? And my neural impulse is going to be blue. Okay? This is where actual transduction occurs. So what is transduction? I'm going to write it right down here. Transduction. You're going to hear that word over and over and over again. Transduction is the conversion of an external stimuli. In this case, what is it? What? Sound, yeah. Sound into a neural impulse. Because if I open up your brain skull, if I open up your cranium or your skull and start shouting at your brain, is your brain going to process that information? Hello? No, no. If I open up your brain and cover your ears and yell at your brain will not process the sounds I'm making because your brain only processes neural impulses. So in order for your brain to process the information that you're hearing right now, the sound waves have to be converted into neural impulses, and those neural impulses is going to occur by transduction. So transduction is taking light and making it into something we can see in our occipital, in our brain. Taking sound and letting our brain process what's happening. Transduction is that process. Okay, if you shine a light on someone's brain, they're not going to see it. Your brain doesn't process light. Your brain processes neural impulses about that light. All right, so transduction. Transduction occurs on the basilar membrane. Okay, so as the mucus moves, okay, it is going to happen. So transduction. Woo! How exciting. Okay, so this is right here your auditory canal. Your auditory, no, not auditory canal, auditory nerve. This is taking all that information of transduction from your cochlea to your occipital lobe. No, auditory. I'm sorry, I'm getting all confused. Auditory cortex. There you go. To your temporal lobe. All right. These right here have nothing to do with hearing. What are they? Does everyone know? Balance. It's your semicircular canals. And those are going to come in important in week 2, sensation and perception. And this is your balance. And that's your kinesthetic, where you get that sense. Okay? Have you ever noticed if you got water in your ear that you just feel like your head weighs 5,000 pounds on that side? Like, just so heavy. Like, you just notice your head kind of drifting down all the time because it's so heavy. The reason why it's so heavy is because it's so close to your center of balance, which is your semicircular canal. Okay? All right. So, the inner ear is everything from your oval window all the way down to your inner ear. Okay, I'm going to write it down here. Okay, and this is going to be liquid is going to be what it's dealing with. And it's going to go oval window, cochlea. Okay, inside the cochlea you have the basilar membrane. And this is important, so I'm going to put a star and write transduction. Okay, then it goes to your auditory nerve. Then to your temporal lobe. Then to your auditory cortex. Oops, sorry. And then for me, it's going to be pink. Okay. And it is, don't color your semicircular canals because they're really not involved in hearing. Okay, but do color in your whole cochlea. Make sure you color in your basilar membrane. Okay, and then your auditory nerve. Okay, so there is your ear. So what we're going to do now that you've colored it all, we are going to make a running list of how your ear processes auditory information. So the first step, I'm writing it way over here, is the pinna. Pinna is filtering information in. Then it goes through your auditory canal. So on your test on Thursday, it's going to ask you which of the following is correct for how the ear processes sound. And this would be it. Tympanic membrane. Okay, I'm going to draw a line. And I'm going to write outer ear. You do need to keep them separate. I'm going to draw an arrow up so I know exactly what I'm describing. 4 is your ossicles, which is anvil, hammer, stirrup. Then it goes to 5, your oval window. Then I'm going to draw a line, and then I'm going to write middle ear. And then I'm going to draw an arrow up because the middle ear is there. And then I'm going to write 6, cochlea. Then it goes to 7, your basilar membrane. And I'm going to put a star because this is where transduction occurs. Then 8 is your auditory nerve. the 9 temporal lobe. And then 10, your auditory cortex. And this, I'm going to draw a line. I'm going to write inner ear. Then I'm going to take my colors, whatever they were. So blue is my outer ear, so I'm going to quickly color my blue outer ear. So everything is the same. Then my yellow is my middle ear, so I'm going to color that. Now please note that I didn't rewrite tympanic membrane twice. It's just a progression. Does that make sense? Hello? But we understand that the tympanic membrane is the end of outer and beginning of middle, yes? So just because I didn't write it on the major list does not mean that they're not a part of it. It just makes it a little more clear. And then pink was my middle ear, inner ear, so I'm coloring that super quick. All right. That is your ear, my darlings. How do you feel? Are we excited? Good. All right. So that is your ear. And we'll begin working on our eye for right now.